kind of structure and answer some questions here, just kind of about what is going to happen. So I do not have your quizzes graded. Also, not everybody has taken the quiz, so I don't want to like just, blanket hand them out. So if you have not taken the quiz, you need to make arrangements with me to do it today, if at all possible. If we can't do it today, then we'll need to make some arrangements that I want to plan with everybody today, okay? The reason for that, number one, is that I would like to give you quizzes back tomorrow. The other piece of it is that I'm actually going to be out of the building both tomorrow afternoon and all day Friday, okay? So I've got some other stuff for you to be doing during those days, but I'm not going to be here to help you, to teach you, to give you quizzes and that sort of thing. So please, if you have not yet taken your quiz, take it or talk to me today. If not, take it today. I'm free as always, all the time, I guess. And but we do have Liberty Time today, so that's nice and convenient. My plan in terms of a test for this unit, I am not planning to test this unit because I feel like it's really just two little things, right? It's really vectors and it's really projectile motion. And those things are important to me. But I want to take a look at the quiz first and see how you do. And I really just kind of want to go with that and not, because there's not one like thing that's going to really tie it all together like there was last time with the free fall. If your grade on this quiz is not where you want it and your last quiz is not where you want it, let's talk about doing a retake and let's just do it that way. Does that sound fair? So I will get those hopefully graded tonight and then follow up with that. And we can address those questions kind of individually as opposed to testing. Unless you guys really want to take a test. Is that true? I'm guessing no. Like usually when given the option, people are like, why would I want to take a test? Okay, so that's where I'm going to go with that. Today we're going to start a new unit. A unit that is really going to kind of like, it's like the quintessential physics stuff. So we're going to get started with it and we'll talk about it a little bit today and then we'll really jump in next week. I don't have any homework for you tonight. Because unless you want some, I can always come up with some. But I feel like today's going to be just kind of a like laying the groundwork kind of day. And then after that, we will start kind of digging in. Okay. I did have an interesting conversation with a few people kind of sporadically throughout the last couple of days that I wanted to throw out to you. And that is, I know that projectile motion mathematics was hard. It is the hardest computation stuff that you will do all year for me. Okay, so you have made it over that. I'm not saying that everything's going to be easy peasy, no problem, but that is the most complicated calculation stuff that you'll do all year. So hopefully that's a relief for you. There's a lot of content stuff, but it's not like you have to go through a bunch of algebra to spit out an answer. Okay, so for what it's worth. Questions about the plan? Can we jump in and get started? Sweet. So pull out some notes because we're going to jump in and do some notes. It's going to be great. So when you mention to somebody on the street, hey, I'm taking physics, or hey, I love physics, or whatever, blah, 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 blah. There are two kind of big things that people will remind, or will kind of like that'll trigger in their brains. One is like what I call kinematics, the motion problems, right? Like we were, my uncle and aunt were here this weekend from Maryland. They're Maryland grad. They came out for the game, which was very successful for us and a little sad for them, but that's okay. We had a lovely time. But we were on the train on the way to the game, and my uncle was like making some joke about, the train leaves so-and-so at such and such a time, and when will it get da-da-da, like those kind of like typical problems. That we've already done. That's the motion stuff that we've already done. The other big topic that people think of when they think of physics involves a word that we may have like mentioned in hushed tones, but we haven't really articulated before until today. So here it comes. Here's the word. The word force. Okay. So I'm going to give you just a minute, and the answer might be a short one, or the answer might be a long list. See if you can write down your brain, your thought process. What is a force? What do you think of when you hear that word, force, in the context of what we're doing? Just go ahead and write for a minute. Let those juices in your brain start to mix up and flow. If you want to talk to each other about that, that's fine. Have a conversation. What does it mean? What is a force? I don't know. You could write down anything. It doesn't have to be just a definition. But what other things do you think of when you think of force? We're making a big list. So write down as many as you can think of. Might just be one. That's okay too. Bless you. All right. Do you guys need another moment, or do you have some stuff written down? You ready? All right, we're going to go table by table. So share what you got. We'll start back over here with my friends. What you got?
So I was going to say like a force is kind of cool. When I think of force, I always think of motion because like a force gives something motion, whether it's potential or kinetic kind of.
Okay.
So thinking of motion, maybe think of Newton's laws.
That's a lot of stuff. I mean, I don't think you should sell yourself short. Like, that's pretty good. So you said that a force makes you think of motion. Oops, come on, silly thing. Why are you not working? There we go. Makes you think of motion. Makes you think of, what else did you say? Kinetic and potential energy. And then you said something else too.
It goes along with motion, but it is three laws.
Mm-hmm. Awesome. All right. What else did you guys say? A push or a pull. Awesome.
I can't think of the word, so I just said an outside action on an object.
Cool. This is awesome, you guys. All right, Stella, what else did your table say?
Something that
does something.
That's a lot of somethings. Let's write it down. Say that again. Something. Okay, hold on. Something that does something to something. Okay. We might have to fill in some of those somethings with other things, but for right now, we'll leave it there. What are we saying back there?
I said mass times acceleration.
You said mass times acceleration. What else? I didn't talk to every single person. We've gone through every table, but what else you got? Requires energy? What else you got? What else? Patience, what you got?
Is gravity a force?
Gravity is a force. What else? What else? What else? Yeah.
Centripetal force.
Okay. Thank you for saying a not offensive word. I appreciate that. Don't do it. Just start screaming. Centripetal. Yeah. What else? Do you guys want to see if maybe you can think of, because I hear a couple of examples. Are there other examples of forces that you can think of? Go, Ben.
Isn't there like centrifugal?
Oh! Say that again. Say that again.
Come on.
I gotta collect myself again. Hold on.
trigger.
We'll get there. But that's a terrible, terrible word. It's a bad word. It's like not appropriate for school kind of word. Okay, like there's lists of them. But you didn't know, right? It's kind of like, you know, my daughters. It's funny because when kids are really really little, I don't know if you have any younger siblings that you notice about. Like you can listen to like any music with them when they're really little because they're not going to start repeating things. But there's an age at which you have to like pay attention to what music you're listening to because they're going to start singing the words, and you're like, maybe those are words you don't want to be saying out loud at preschool in front of. You know what I'm saying? You didn't know, right? So like when my little girl starts singing, like I don't even can't think of an example, but like something that isn't super appropriate, and then I'm like, oh, okay, maybe no more of that. You didn't know. So I'm gonna have the conversation that I have with my little kids. We don't say that word. It's not okay. When you get a little older, in a couple weeks or a couple months, we'll talk about why you can't use that word. But for right now, yeah. The only reason that he knew is because he said it earlier. Yeah. And so we've had this experience. So it's okay. No harm, no foul. It's all good. Go.
So I didn't hear the word.
Oh, don't. It's okay. It's one. La 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 la. We'll talk about it. We'll talk about it in a couple months.
I'm grown. I'm already here now.
I'm not gonna say it. I don't want to get in trouble. They're gonna fire me if I say words that are inappropriate. No. We're gonna move on. We'll talk about the bad word later. Go.
Would an example of force be inertia?
Ooh, that's a fun word too. I will tell you. INER. You know that reaction that I just had to the bad word that Ben said? The physics teacher at West screams and cries when you say that word. This word I also think is pretty bad. I feel like this is one of those words that like you don't say in front of your grandma, but like in, you know, friend company you can kind of say. So we'll talk about why that word is not like do you know what I'm saying? Like there are levels of bad words. Yeah, so this one's kind of like moderately bad, but it's not terrible. We'll talk about why in just a minute.
Oh, physics.
What else you got? What's that? Your physics grandma?
No, physics terms, I thought.
Oh, yeah. No, these are important things. Any other things that you can think of? Any other forces that you know of or that you've heard of before that you want to add to our list? Yeah.
Mass times velocity.
Mass times velocity. Did I see your hand? Or was I dreaming? No?
The unit for force is newtons.
The unit for a force is a Newton. You guys know a lot about forces. Other things? Go.
Is inflation a force?
What do you mean inflation? That word has lots of
The
meanings.
universe.
Like the expansion of the universe? So we could say that the expansion of the universe is occurring because of forces. Right? Like I would say that the expansion is a result. Yeah. Is that fair? Yeah. It actually has to do with acceleration. We'll get there in just a sec. Yeah. Any other words that you want to add? This is this is the entire board worth of list. That's awesome. Okay, so now I'm going to kind of piece it out. So if you have all this stuff written down, that would be awesome. If you don't, then as I'm going through, you might want to write some of them down. But I want you to pay attention to the conversation. So maybe write them down kind of as we go through them. So motion, absolutely. Force has to do with motion most of the time. Okay, but they are intimately related. So that one, we'll call that one good. We'll keep that. The kinetic and potential energy are related to force kind of, and we'll get there. I'm going to put this one in a little, put this one in a little box and say, we're going to do this actually in unit, what are we in 3? So probably in unit 5. So it's not that it's not related. It's just when we're doing the very basics of forces, I'm not going to do this yet. It's kind of like thinking back to my preschool age kid, right? She doesn't know how to multiply yet, but she likes to count, right? And counting and multiplying are related, but we don't want to just throw in multiplication right this moment. Does that make sense? So that's kind of where I'm going to go with this one. This one right here, I don't want you to recite them for me, but raise your hand if you think you could tell me at least one of the Newton's 3 laws. Keep your hand up if you think you could do 2 of them. 3 of them? Okay. Here's the deal. And this one, we're going to come back to this today, and we'll do this for like a bunch of days. The Newton's 3 laws, the way you've been indoctrinated to them, I want you to forget. They're gone. All of that time you spent in foundations, all of that time you spent whenever learning those 3 laws, I'm not saying they're wrong. How many of you, I don't remember, I don't know when this ended or started, did you guys have to recite the Pledge of Allegiance when you were in kindergarten?
Yeah.
Right? So you imagine these little 5-year-olds, right, standing up, I pledge allegiance, blah, 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 blah. They say words, right? And you say the words and you repeat them. But when you were 5 years old, do you have any idea what you were saying?
No.
No. Like you could be saying some crazy stuff about hippopotamuses walking on the Sahara. Like you don't know. Like it doesn't matter. Their words mean nothing to you. And my sense is from teaching this for a number of years that people memorize Newton's 3 laws. I have no clue what they mean. So I'm going to teach them to you in a better way. Okay. So that's my goal. So we'll leave that there. I also have issues with Isaac Newton in general. We'll get there. Okay. So we're going to relearn these this year. Okay. Because that's super important. This answer right here is perhaps one of the simplest answers that was thrown out there. That is my number 1 best definition that I see up there. A push or a pull. A push or a pull. It's simple. A force is a push or a pull. Right? What could happen? I'm going to apply a force to this chair. I did it. You with me there? I'm going to apply a force to this chair. I did it, right? That is what a force is. Boom, that is it. Okay? And then these two right here, I mean, like this happened in a really lovely way, the way you guys did this. These two really mean the same thing. Let's read them again. So outside action on object, something that does something to something. I'm going to rewrite this one. So if you don't have this written down yet, write it down now as I'm fixing it. Not fixing it, just adjusting it so it's a little bit more clear. I'm going to take this first something. I'm going to change it to one object. Okay. That does something. What kind of something? Like, takes it out for pizza?
Pushes or pulls.
Pushers or pulls, right? Oh, come on, stinker. Why is this? Seriously? What's this really? Yeah. So something that does something to something is right, just very vague. But if we say instead of something, just one object, and that does something is really pushing or pulling, and to another object is the other thing. Like this right here, that's another one I would put a little highlight through. One object that pushes or pulls another object. For sure, there it is. Okay, that is a force. We've got some fancy equations here. Mass and acceleration and mass and velocity. Mass times velocity is actually not force. It is something we're going to do in unit 4. So I'm going to put a box around that one, say that's for unit 4. Mass times velocity is something. But I don't want to confuse us, so I'm just going to throw it over to unit 4. Mass times acceleration is something. This is another thing, though, that you've been indoctrinated to know. Right? Okay, I gotta know it. But you don't know why. We're gonna talk about why. So again, this is one of those things that we're gonna relearn. And I'm not at all, I want to make it really clear, I'm not trying to throw your other teachers under the bus. Okay? Because they were teaching you not in a physics class, but in a, foundations class. They were teaching what they were supposed to. Yep. But now you're here. And now you get to learn the real stuff. Okay? And the real truth of it, friends, is that all of the stuff that I teach you in some way or another is really just fake. It's not really true, okay? And if you go to college and you spend all 4 years in college studying physics, then at the end of that, you realize that all that is fake too. It depends on at what level you're looking at things, right? So what we're learning is true, but it's not true at the fundamental level, and that's the kind of funny business here. So I just want you to relearn this in a way that makes sense. This energy business, again, I'm gonna. What? Stop! I'm not talking to you. Like, what are you doing? She's never done that to me before. That's creepy. Stop it. That was weird. Wow. This is Unit 5. Oh yeah, Newton. Oh wait, that's the unit. Yeah, that's true. That will take. Unit of force. We're gonna find out why that's true in a minute. Gravity will do soon. Centripetal force happens in, I don't know, like Unit 8. I'm just making that one up. Centripetal. Right, Ben? We'll call that Unit 7. I don't know for sure. And inertia we're going to talk about in a minute too. Just gives me like, it's just like that, ooh, I just said the word. It's kind of, all right. How are we doing so far? The key here, friends, there are two keys. One is that there's a push or a pull. The other one that we kind of articulated, but that I want you to write really big with stars and glitter and, you know, whatever it needs to be, is that a force is an interaction between two objects. Always. A force is an interaction between two objects. So in this unit, we're going to learn to name forces. We're going to learn to quantify forces. We're going to learn to get to know forces. It'll be great. All right. Anytime you label a force, you have to include how many objects? Two, because it's always an interaction between two objects, right? All right, let's start. Okay. Example number 1. How is Barbie? There he is. I'm going to teach you now how to kind of document this. We're going to draw what we call a free body diagram. A free body diagram is a picture of an object. It includes one object and all of the forces acting on that object. So we're going to start it out pretty simply here. Okay. Free body diagram. I'm going to draw a free body diagram of my frog. There's my frog. You can draw it as a box. You can draw it as a dot. You can draw a frog if you're feeling artistic today. My question for you is, there he is. He's sitting so attentively. What forces are acting on my frog? Gravity. That's always the first thing that people say, and I love that. But then I'm going to ask, because I'm going to point out to you that you just agreed with me that it has to be an interaction between two objects. So here's my question for you, ladies and gentlemen. What object is pulling on my frog that we call gravity? What object pulls on my frog that's the thing that we call gravity? I hear things. I heard air. I heard earth. Other ideas?
Wait, can what it's sitting on push up?
For sure it can.
So is the frog then pushing down?
Right? Yes. Yes, there's like tons of stuff going on in your head. I love it. Oh my gosh, that's so exciting. Okay, so here's the thing, because patients, what you're saying is absolutely correct.
The only thing I remember about 7th grade science is if you push on a wall, it's pushing better.
Yep, and that we're gonna do in Unit 4. So that thing that you've memorized because somebody told you it maybe, or maybe you proved it. I don't know. Did you like slam your hand into a wall and like, oh man, that hurts? Yeah, we will get there. But I like to teach that law separately because I feel like it is very separate. It's funny. You guys don't know the physics teacher at West. I like him a lot. He's a good guy. We teach physics very, very differently.
Oh, exactly.
He teaches Newton's first law and third law together. I think that's nuts. I teach Newton's first and second law together, and then third law is totally separate. So, you got me, so you're stuck with me, so we're doing my way. So we'll get there in just a second. And by a second, I mean, in a week or 3. But patients, you are absolutely right. There is a force pushing up on the frog. What's pushing up on the frog?
The chair.
The chair. Let's draw that. We got really good at vectors in the last chapter, you guys. And now we get to use our expertise. So we're going to draw an arrow. Okay, a force is a push or a pull in a direction. Okay, it's got a magnitude or a size and a direction. I'm going to draw that arrow, and then I'm going to say the force of the chair on the frog. And yes, you need to label it just like that. And if you need extra graphite or you need an extra pencil, I can get it for you, but I want you to label it like that. Why? Because it's the force of one object on another. I totally evaded the gravity question. Did you catch that? That was kind of sneaky of me. What is it that's pulling on the frog that makes this thing called gravity happen? What object is it that's pulling down? Is the chair pulling down on the frog? You guys had it before. The earth. The earth is pulling down on the frog. This force here is the force that is commonly known as the gravitational force. Or gravity for short. Okay. I want to define what gravity means. Hold on just a second. Okay. Does anybody know how the gravitational force works? That's exactly right. That's exactly right. Okay. It is, we're going to write this down. It's always an attractive, and by that it doesn't mean like you did your hair and you're like wearing fancy clothes, but attractive in that you're pulling together, okay? Attractive force between any two objects with mass. Have we talked about mass? Maybe we mentioned it a little bit. What does it mean to have mass? Okay, I heard a lot of things. What did you say?
Like, if a massive matter.
So it's something that's made of matter. Yeah. But Patience, you said something else too. What did you say? Takes up space? Yeah. Yeah, let's write that down. Okay. So it is made of matter. It takes up space. Yeah. Most things that we think of, all objects that we think of are matter. They have mass. Okay? The more matter they have, the more mass they have. Okay? Literally, that's what we're talking about. You know that all objects are made of atoms, right? And atoms are made of protons, neutrons, and electrons. And the protons have mass, and the neutrons and electrons have mass. Everything has mass. It has stuff. That's what we're talking about. Any two objects with mass have a gravitational force between them. Okay? I have a gravitational force that is attractive towards the frog. I'm pulling on the frog. Is that weird? You're pulling on the frog too. So are you. So are you. Why isn't the frog going phew, flying towards you? What gravitational force is stronger? Mine? The Earth's gravitational force is a whole lot stronger. Why is the Earth's gravitational force a whole lot stronger? Is it just in practicing more? It has more mass. The bigger the mass, the bigger the force. Does that make sense? The bigger the mass, the bigger the force. That's another thing that's good to write down. True. So I'm pulling on the frog, and Isaac is pulling on the frog, and Moshe is pulling on the frog, and everything is pulling on the frog, but really the thing that matters, because I said somewhere that a free body diagram was one object and all of the forces that are acting on it. So we could sit here for hours and days and years and draw all of the things that are acting on the frog, right? Because I'd have to draw all of you, I'd have to draw all the tables, I'd have to draw all of the floor tiles and all of everything. But really, there are two things that are really acting on it and making a big difference, right? And that is the chair pushing up and the earth pulling down. We can calculate the gravitational force or the gravity on the frog, of the earth on the frog. Does anybody know how we do that? What's that? It is, but it's a specific kind of acceleration. But it's a kind of acceleration that we've talked about. It's the mass of the object times the acceleration due to gravity. Yeah. A sub g, or sometimes we write that just as g. And what value does this have? It does. Is the mass of an object ever going to be negative?
No.
Doesn't make sense. So what do you notice if you're multiplying some positive number by this negative 9.8 meters per second squared? What do you notice about the direction of the earth on the object?
It's negative.
Always going to be negative, right? It's always going to be negative. So we can make a note that this right here is how we calculate the size of the force, the direction, always, we think of it as down. Really, it is toward the center of the earth. So you take the mass times the acceleration due to gravity, and you find the force of the earth on the object, okay? The force of gravity. Sometimes we write that as F sub g, but really it is the earth on the object, and that's what I want you to keep in your brain, okay? It's always pointing down toward the center of the earth, and it's something that we measure a lot. It's something that, because of our society and the terrible construct in which we live, a lot of people are very, very concerned about the force of the earth on them. It sounds funny when you say it like that, doesn't it? Yeah. But I know that the construct is in the heads of so many teenagers, whether it's because you wrestle and you need to make sure that you can wrestle in a certain class, or because you have this construct of what your body image should be. You are all beautiful people, right? And you all need to know that. But we have, for whatever reason, because society is a lot, that we need to watch our what? What do we need to be aware of? Our weight, okay? The force of gravity, the force of the earth on you is what we often will call our weight, okay? Yep. Go ahead. Yep. It's also known as,
Wait, when you say it
The force of the earth on the object. So the force of the earth on me, is the gravitational force, but we often will call that our weight. Okay? So here's a weird thing, guys. We worry about weight, right? You go to the doctor and they take your temperature and they take your blood pressure and they weigh you. Okay? And they say, oh, you weigh blah, blah, blah pounds. That's not the really unit that we're going to use, but we'll just pretend for a minute. If you happen to be in any other country except for the United States and Great Britain, because they don't use freedom unit. That's terrible. Like, that's so bad. Like, I can't even believe that I acknowledged that you said that, but I'm just going to move on from right now, okay? If you go to the doctor and they take your temperature, they take your blood pressure, and they put you on a scale, what do they measure? They measure it in kilograms, right? Which means that they're measuring your mass. So we're going to make a little chart over here because we want to make sure that we understand this. There's so much good stuff that's happening right now. Oh, my goodness. Mass versus the force of the earth on you or your weight. Okay. What's the unit that we're going to measure mass in? Kilograms. Indeed. We've kind of started talking about that already. You talk about that in chemistry. Although in chemistry, remember we talked about this at the very beginning of the year, you just talk about grams, not kilograms, right? But you got that idea. The force of the earth on you, your weight, what do we measure that in? We measure it in pounds because we're in America, and that's goofy. If we were somewhere else in the world and we were talking about our weight or the force of the earth on us, what units are we going to use? It's a force. And the unit of force that we use, or the unit of force we use is a Newton, right? What is that? I'm totally serious. That's weird, right? I agree. Yeah, we'll figure out how much we weigh later. That's today. But yes, you would use a Newton. N stands for newtons. And we don't today have time for me to tell you all about the terrible things about Isaac Newton, but soon we'll get there.
But we wouldn't hear.
Not today. I promise it will come. But I have to get through a couple more moments, and it's a longer story than a 10-minute story. That's the thing, right? Like, it'll go on. So I have to get over it. All right. Another thing that we need to write down about mass versus weight. So how do we measure? How do you measure your weight? Step on a scale, right? Do you guys know how a scale works?
Oh my gosh, Josie. No, you can't be sad to yourself. That's my thing. That's my thing, though. Yeah, but that's my thing.
It's like
It was my thing before Dad was born. December 6th, 2008.
still.
All right. So, when you step on a bathroom scale, they're the old school scales, the ones that have the little needle, right, that move back and forth, right? And then there are the new fancy ones that have the digital readout. And I don't know what kind you have at your house if you have a scale, but let's talk about how each one of them works. So, the ones with the needle, actually what it has a little spring or a little coil in it. And basically what happens is that scale pushes down and it makes the coil go smaller, and that makes the needle move. Like, literally, that's what happens, okay? So it is really applying a force up on you, okay, that's equal to the gravitational or the earth force down on you, okay? This is a simpler version. This would not be a safe thing to try at home, but he's little and we can do it. So this thing is called a spring scale, okay? So literally, I'm going to hang him from there. Whee! Like, yay, this is so much fun. I love doing this. There he goes, okay? And so the spring is going to stretch a certain amount. Are you with me there? The spring is going to stretch a certain amount based on the force being pulled down. So there's a force of the earth pulling down. There's a force of the scale pushing up, right? That makes sense? And that's how we measure weight. Okay? How we measure the force of the earth on us. Boinky, 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 it's fun. Okay. Any idea? I'm going to write that down so I don't forget. We're going to use this measuring it or using a scale. Oh, and by the way, if you do the digital bathroom scales, it has basically it's a resistor that changes based on how much it's pushed. And so it sends a different amount of current through a circuit. And that amount of current is then read out. That's essentially what happens. How do you measure mass? Do you know how you measure mass? Does anybody's doctor's office have one of those super old school scales? Or not scales, but mass measurers?
Is it like
where you
the
step on it?
two
With the little things,
the really
right?
confusing one.
Yep.
I
They
remember
look
doing
something akin to this. Yeah, I mean they don't put you on the bottom. Although honestly, when you bring a baby into the doctor, it like they set them on like a little they have like a little tray right there that you put the baby on. It's kind of strange. But yeah, so literally what this is doing is this is a little teeter-totter. How you guys remember teeter-totters from when you were little? Okay? And it balances out until you get it so that it's balanced out evenly. Okay? And so this is calibrated so that it'll balance at a certain spot, and that spot where it balances is exactly where the mass over here equals the mass over here. Okay? So they use a balance to measure mass. There's a reason I'm telling you this, and not just, for fun. I mean, it is fun too, but this is the reason. Mass versus weight. Which one, if either, changes when you go to the moon? What? Wait, what? Is there something you need?
No. Oh.
That's fine, right?
I get it.
What's that? That's a carpooling joke right there. That's what that is. Yeah. All right.
Wait.
What? Your mass, remember mass is, where did we define that? Oh, it is up here. It's made of matter and it takes up space. So let's say that you volunteer to be an astronaut and you're going to go up to the moon and it's going to be very exciting. Your mass, when you leave, unless you have some sort of terrible situation where you lose an arm, right? Or you lose some, you know what I'm saying? Your mass, when you leave, should be the same as when you arrive. Are you with me there? Your mass doesn't change. The amount of stuff that is you is the same. Okay? So, is that one going to change? No, because it's the amount of stuff. So, no. But the force of the earth on you, there's a key, there's a trick there, right? Because when you go to the moon, if I take my froggy to the moon and I take my chair to the moon, I'm going to do the whole thing. We're going to set up a little classroom on the moon. It'll be so much fun, you guys. So I'll take my little chair out. You guys all sit down just like this. And then I'll put the frog right here and I'll say, okay, what forces are acting on the frog? And you'll say what? The moon will pull on the earth. And oh! Yes! All right, here we go. Da-da-da-da-da-da. I love this. This is so good. They didn't, no, but they said another thing that's so exciting. Is there gravity on the moon?
Doesn't it have a whole gravity?
Is there gravity on the moon? By that I mean, because I want to make sure it makes sense to you, friends. Because if I say, is there gravity on the earth, you're saying the earth is pulling down on my frog, right? There's gravity on my frog. Is there gravity? Is there a force between the frog and the moon?
Yes, but it's smaller because the moon has a small.
High five to you. Yeah. Yes, there is gravity on the moon. For sure. Because we know, oh my gosh, you guys, this is so cool. Because we know that the moon has mass, right? The moon has mass and my frog has mass, so there's got to be an interaction between the two. Absolutely. But as Malik just said, does the gravitational force, is it the same? It is not. Because when you calculate the force of the moon on you or on the frog, okay, it's going to be the mass of you times the acceleration due to gravity, but on the moon, right? This thing is less than 9.8 meters per second squared, okay? We can figure out what it is. We will figure out what it is eventually, but for right now, you just know that it's less than 9.8.
Wait.
Yes.
9.8 is negative.
Yep, negative.
And that which means it's close.
The magnitude will be smaller. Yes, the magnitude will be smaller. So, the game is, ladies and gentlemen, okay, again, social construct says everybody needs to lose weight, whatever, right? Like there are things that are good about being healthy and being a healthy weight, but everybody needs to be the healthy weight for themselves. But let me say this real quick, because I know it's almost time to go, but not quite yet. Here's the thing. One way to lose weight would be to go to the moon. That's exactly right, but is that really what they mean?
No, because you can't know that.
You really want to lose what?
Mass.
You really want to lose mass. You got it.
So the new slogan, lose mass.
Lose mass! That's right. You got it. You got it.
So if you